Welcome everybody to Dallas Personal Robotics Group Robot Builders Night Virtual for Tuesday, March 3rd, 2026. Tonight we will do our normal housekeeping and then go through a list of presenters to show off their robot projects. And then we'll open the floor to any questions or comments that people have. So start us off. We have, in housekeeping, we have a competition coming up very quickly. So May 24th weekend, I think it is, around there. And it will have several competitions. Quick trip, line following advanced, barrel racing, 6-can, 4-square, and sumo. So there's all sorts of opportunities to bring a robot and, to try to compete and maybe get an award.
Yeah. Or just come along.
Or just come along and support the guys that are working. Usually we get a pretty good turnout at the Dallas Makerspace.
Yep.
We also host occasionally we try to a parallel contest up north here. I'm from Canada. And a couple of us try to get together and see what we can do at the same time as you guys are competing. So we will have that as well, probably. So tonight, list of contests, and then Mark is going to give us a quick update on our Robby robot rebuild.
Yep, sure. So yeah, as you know, we have a club robot. And we've had him since, I think, 2014. He was built originally. Anyway, he's deteriorated over the years. And we started rebuilding him last year, but then we went on hiatus for numerous things, including the New Year holidays and whatnot. But tomorrow we're going to get together at the Makerspace around 6:30. And Mark and I are going to start work on him. And if anyone's available to come hang out with us and work, or just hang out, yeah, we'll be at the Makerspace. And if you're not a member, just message one of us and we'll let you in and whatnot. So yeah, we'll be there.
So are you going to try to keep some of the internals, or is it?
Yeah. One of the main things I want to do though with our current Robby is change out the power supply, because right now he has a little extension cord in his gut with a laptop power supply, a couple of wall warts, a couple of USB. It's a lot. So I want to make like a little power board, power distribution board, and do things a little cleaner. Yeah, that's my main goal. And then Mark, I know Mark wants to look more into how it works and where we can go from there and restoring. So, yeah.
Yeah. So is it? I thought you said it was like fishing line.
Oh, it is
controlled more or less.
Yeah, on the shoulder, there's two motors. One that makes it go forward backwards. One that makes it go out. Yeah, it's fishing line wrap round a motor. I mean, it's really well done. It's a really good mechanism. But yeah, it's wood and fishing line in there. So it's
maybe take a few pictures and post some up on the Discord server.
Sure,
it would be nice to see.
Yep.
Okay, well, thanks, Mark.
Even for 2015, it seems like there could have been a much more modernized design.
Yeah.
No,
maybe. Yeah.
Or was it made from a previous platform in
I don't know,
the middle 80s or something?
Yeah.
I know it's a really neat construction though, the way it's constructed.
Yeah.
All out of laser cut wood.
Yeah.
Did you say middle 80s or middle ages?
Both, yeah. I thought it was older than that.
Same difference.
No, Doug might know more. Yeah. Yeah. Cool.
Okay, thanks, Mark. Next up, for our first presenter, we have Phil. Phil is new to the group. He went out to the meeting last weekend and decided to join us online. So welcome, Phil.
Thank you. Yeah, so this is the project I've been working on. It is a kind of two-legged, two-wheeled robot. Kind of wheel's going to go like that. The axle might be a little bit long. I'm going to trim that eventually. but for now, it's just the full size rod. There is, if you take the lid off, there is a motor inside and some gears that just lets this lift up and down. I'm going to try not to hit the monitor, but essentially this just goes up and down. And I'll have a motor mounted right here for the wheel. Yeah, and then that gets mounted onto a base plate, right? Something like that, and it'll drive around. The other leg is printing right now and starting to learn ROS and get that, starting to figure out the code side of things.
So you're using three-phase brushless motors in it for wheels and for the joint, I guess?
Yeah, it's the same motor for both the wheel and joint. Yeah, these are the motors, and then I've got a controller board.
Yeah.
What's the controller board you're using?
It's a Modius R4. I've got one right here in the SD pad. Yeah, here's the board. It's got just a little power and then CAN bus connection. And then it's got an AS5600 or whatever the encoder is right there on the back that just mounts up on the other side. But yeah, that's it.
What are you using for a controller?
For now, it's a Raspberry Pi 3. I'm not sure that's going to be powerful enough. I'd like to do some AI image processing stuff at some point. I don't know that a Pi 3 is going to cut that, so that might get upgraded to something a little bit better at some point in the future, but for now, just a Pi.
Okay, thank you.
Yeah.
And that's all 3D printed? Oh.
Yeah, it's all 3D printed. There is a bracket that holds the controller onto the motor that is aluminum because this gets a little warm.
Yeah.
But yeah, other than that, it's all 3D printed.
That's cool. Can't wait to see it.
Thank you.
Yeah. Philip, do you only have the one computer on board your robot according to your current plan?
Yeah, right now it's just the one computer. I'm gonna have some kind of power distribution board, but I have to design that. So for now, it's just kind of XT30s.
I tried for a long time to stick with one computer, but I'm rapidly moving towards more than one. Specialized applications. As soon as you get into video processing, it starts to make sense to isolate that out.
Oh, so you have like two separate like.
I'm using a specialized NPU for processing images.
Okay. I was looking at the Oak Light, and that might do a lot of the image processing, but I haven't really decided on cameras or too much of the sensors yet.
I tend to go low scale, at least to start with, and I have used the Grove image processing board.
Okay.
TPU, and I have also used the ESP32, the ESP32 cam, and have done. Yeah, I mean, don't get excited about it. You can make it work, but you'll be holding your breath waiting for numbers.
Okay.
You can get a couple of frames of update per second, depending what you're trying to do.
Okay, that's not too bad.
Yeah, I've used it for cone detection and got 1.5 updates a second, and I'm now working on using it to identify April tags, and it will run probably 5 or 6 frames per second. But I've got half a dozen ESP32 cams kicking around here, and they're just so easy to use, and that seems like a nice dedicated application.
Okay, yeah, I'll have to check those out.
The Grove is very nice, and it's not very expensive at all. But some of the higher powered units that you talked about certainly will be much better.
Yeah. Yeah, that's pretty much all I had. Are there any other questions? No.
You mentioned ROS. Did you mean you're using ROS 2?
Yeah, ROS 2.
Sure. Yeah.
So does it not matter? I thought it was primarily geared towards DC motors. Does it support three-phase brushless motors? Or is it not relevant? You just send it a velocity command or whatever velocity command or something?
Oh, so you send it a command velocity position, and then it has an onboard little microcontroller that has all the pit loops and everything to basically do whatever you tell it to.
Oh, okay. So that's kind of the interface with ROS. It's
yeah, they have a pre-made ROS2 node. So I'm going to try using that, and you can just send it over a service, send a command over a service.
So I guess it's all kind of fitting in with the publish subscribe. You just have, I guess, maybe 2 nodes that subscribe to certain commands or whatever.
Yeah, they also have just like a Python or C library that you can plug into and just send commands over their protocol.
Does that driver, is it using like some form of the simple FOC library, or?
I think it's a custom library that they built. And yeah, it's their software, I think.
Okay.
Yeah, it is. I think it is open source, but
yeah,
but it is their own developed driver for it on that board, similar to the O drive.
Yeah.
Except for I think this one's a little bit cheaper.
It is, yeah. I was originally looking at the O drive, and then I saw how much they cost and quickly changed my mind.
Yeah, they're kind of pricey.
So the motors that you have, what, are they like 12 volt probably for that size, or?
These are 24 volt.
Oh, they are
off a 6S LiPo.
Oh, okay. So what kind of current will the motors draw? Is it less than 1 to 2?
Honestly, I really have no idea. I know these are, they're rated for like 600 watt or something, so they're pretty beefy motors.
Yeah, I'll say.
But I don't know exactly what the current limit is, or like how much it's going to need.
Yeah, you could probably twist a foot right off that thing. 600 watts. It's pretty powerful.
What's
thanks,
the
Phil.
AD rating for the motor?
We're gonna give you a black star for significant progress. Just something we award. Take it for what it is. You'll be immortalized in the DPRG Robot Builders Night videos with a black star.
Awesome. Thank you.
Bragging rights.
Bragging rights. All the bragging rights you want.
Yeah. The goal, though, is the gold star for a working robot.
Yes. If your robot is working, achieving any sort of goals autonomously, then it's a gold star.
Cool. We'll get that next week. Maybe not quite.
Right to the top of the pack. Okay.
I'll make note. Philip said next week.
And get into that rapid prototyping mode.
Yeah. Well, that's good. Looks impressive, and hopefully you get some good progress with it.
Thank you.
Next up, we have Tom with a short update on what he's been doing.
Just some little updates. I think I've mentioned last time or the time before that I was working on a much bigger, much more powerful outdoor robot, but keeping it low key. I had scrounged up a bunch of vintage screwdriver motors, and I'm using them for gear motors. There's one there. It's mounted on a wooden base, which simply makes it easier to move around on the platform I'm using. You can see there's a 3D printed hub, which I have used to fasten the motors onto the big 8-inch plastic wheels that I'm using. That was plan A. I'm now on plan B. I'll show you plan B. And plan B is, gotta get a little farther away from the camera. So that's the size of the platform base I'm working with. And it's falling apart here because I don't have collars on the wheels. So it'll be a differential. It's got these two big wheels on them and a big trailer, which I manufactured out of a smaller trailer wheel. The intent was originally that, okay, there's one down. Originally, the previous plan A had the hubs fastened onto the wheels and the motor bolted onto here. That worked okay, but the wheels wobble too much. So that was not going to go well, and I could just see it getting worse. So that's why I installed the axle instead of just using the hub to hold the wheel on. That's going to be much, much more rigid, but of course I can't do an axial drive anymore. So what I've done is, let me get this out of the way. So I'll move to timing belts so I can move the motor off the axis of each of the wheels. So I've started to print some timing belt pulleys. This is the small one. I don't have the big one here. And I've ordered some timing belts, T5, 10 millimeter wide. The wheel should be rigid enough to allow me to use a timing belt and not have it slip. So that's plan B. It's kind of going to sit on the side until the timing belts show up. And then we'll get back to it and see what else it does. The motors are showing reasonable speeds. They run about 250 RPM at 5 volts, and they have tons of torque. They're screwdrivers, so they have tons of torque. So I'm not worried about those at all. And I've got some high current H bridges to drive them. I planned to, I'm looking at several different ways to get speed feedback from the wheels. And one of the things that I started out doing was some optical pattern tracking. Because I've got this big space on the inside of the wheel where I can put really big patterns. And just for the heck of it, I asked Gemini, which is the Google search engine or database engine AI tool, to create the pattern for me. So it was very polite, took about 10 seconds and produced this pattern. I don't know whether this will show up in my camera very well, but it's got artifacts in it that don't belong there. Weird ones. I just asked it to give me 128 transitions on a 4-inch diameter circle. So it really worked hard to do that, but didn't succeed very well. There are strange artifacts in there. And even though I asked it for 128 transitions, it gave me 112 transitions, not 128. So because I'm now in AI in interrogation mode in the browser, I simply told it that it made mistakes and it should fix them. So it thought about that for a bit, decided that the reason why it had the artifacts is because it was trying to produce the image in a browser window, and decided that I probably didn't have enough resolution to show what it could build for me. So it decided it would give me SVG code files and explained there were several programs I could use to create the images myself on my own computer. So I agreed, and we went through that exercise, and it produced some SVG to do the same thing. And also told me in a very polite voice that it would solve the problem of not having 128 transitions as well. So we took a look at the image, but I could not get the SVG to execute. Errors occur very early in the SVG code. So I explained to Gemini that there were errors in the code and gave it the errors. It apologized profusely and said it would immediately produce a corrected value. So it produced a corrected value, which did not work as well. And I went through about 4 or 5 iterations of that, and the errors it was introducing in the SVG code simply got worse and worse and worse. So I explained to Gemini that I was going to give up and that I was very disappointed in its output. And it apologized profusely and thanked me for trying.
Do you think it was trying to make a quadrature encoding wheel? It kind of looked like that.
Well, I did not ask it for quadrature encoding.
Yeah.
So if it tried, and
it was
suggesting that inner circle is what that was.
Yeah, it was still a fail. It looks like
it failed miserably if that's what it was trying, and it never told me that it was going to do that.
Yeah.
So anyway,
Tom, was this the free Gemini, and did you give it a very long prompt?
The Google search engine. I think it's Gemini 3, but I don't know much about it. But it was a fun experience, and it was quite humorous, actually.
So it's a nice story. I then searched some more for a good tool to build the patterns I wanted, and that's what I ended up with. That's a quadrature pattern from a highly parameterized early Windows program, probably from 15 or 20 years ago, which I downloaded from the Seattle Robotics Society's website. It's perfect. It just works so well.
Yeah, they don't make them like they used to, apparently.
Nope. And it's only about 40 kbytes in size.
Yeah.
Anyway, that got me one of the choices I will try for getting some speed feedback. I'll also look at using some AS5600s. And because I had my 3D printer running for quite a while last week, I also built, you guys will recall the walking robot that was talked about on Hackaday back a week or two ago, four-legged walking robot. So I've printed all the parts and obtained all the servos and obtained the ESP32 for it. And it's coming together well. We will see whether I can build this walking robot or not. I don't know whether you recall that presentation from a couple of weeks ago. It looked very interesting. It's really cheap. The 3D printing goes really well. We'll see.
Yeah, it looks like a cute robot.
I thought so, yeah.
So is it joints at the feet and at the hip?
Yeah, I'll show you a couple of them here. I don't have the servos on. I just mounted a couple of, as I'm working through this, because I'm hand building the rest of it. There's a couple of, these are 9-gram servos.
Mm-hmm.
So one of them is the plastics I had. I've ordered Metal Gear 9-gram servos. Those are the purple ones, and they have just come in. So I tried one just to make sure it fits okay. So there's 2 of the shoulder servos, and they will connect to a, I think the author calls that a femur, and I'm not sure what he calls this one. This is the foot. So these things will connect together and connect up to the one in the shoulder and produce 4 legs. And according to the examples he has on his GitHub and his Hackaday, it just seems to do a really slick job. So we'll see. It'll be fun. Just in between while I'm waiting for parts to be delivered for my bigger robot. That's
I don't know if it's Chinese New Year time or something. I've had some parts delayed for about 2 weeks, and it's just, I think February 22nd was, the last notice of where it was, and it's like, okay, it's a long time now.
I've been getting deliveries here to Canada in 7 or 8 days out of China from both AliExpress and Temu. I've been experimenting with Temu because they have some things and some reasonable prices. So they're all 7 or 8 days out of China to my location in Ontario.
Wow, that's good.
Now I'm waiting for timing belts, and I'm told they will be like 10 or 11 days. I don't know what the reason for that is. They were cheap though. A guy in Ottawa on the Vancouver Ottawa Robotics group, when I was discussing the timing belts on Sunday with that group, I was getting frustrated because finding appropriate timing belts was proving far more difficult than 3D printing the pulley. That turns out a parameterized application in Open 3D CAD was perfect to produce parameterized pulleys. Excuse me. So that went well, but finding a timing belt was proving difficult. He pointed me back to AliExpress, and they have all kinds of them, and they are dirt cheap. They're like $2 each.
Mm-hmm.
Pardon?
We have good luck printing timing belts out of TPU.
Yeah, I only print PLA at this point.
Oh, yeah, that would not work.
You can see my 12-year-old Cruza clone in the background there. Nothing fancy, and I've only ever played with PLA, partly because I bought so much of it, and I'd kind of like to use it up before I try other things. Other filament types, of course, will require some messing around with the calibration and configurations of the slicer, and I have got it working so very, very well for PLA. I really don't want to mess with it. To me, this is just an appliance. It sits here for months not doing anything until I want to use it. I plug it in. I usually have to rethread the filament. I plug it in, I start working, and it just prints. And that's all I want it to do. I get good prints out of it these days. So I have a second identical unit that I bought used from somebody, which I haven't set up yet. And when I switch to a different material, I may set up that second 3D printer just so that I don't mess with the one I've got here that's working so well for me. Pet G was what I thought I might try next. Although maybe that's old school now. I was looking at all the varieties of filaments, and my God, I have no clue as to what most of them are for.
Yeah, or even just the different versions of PLA nowadays, PLA plus, I don't even know what the difference is.
For the most part, there isn't one.
You may have noticed the reel up here is now empty. I get to put a new reel on.
Finally gone through, what is it, like 2.2 kilograms or something? Or no,
Yeah.
maybe it's not that heavy.
1 kilogram, 2.2 pounds.
2.2 pounds. Yeah.
Yeah.
It's 400 or 500 meters. It's a lot of filament.
Yeah. Has anybody experienced, like if you just leave your filament out and, in the extruder, it'll break off above it? Yeah. So I wonder if it's just getting old and
It's getting moist. You keep it dry.
It's getting moist. If you put it into a dryer, it'll recover.
Well, the other problem is if you stress PLA by having like a crink in it where it's going in, it'll break at the stress point, even if it's not getting wet.
Okay.
And it depends on the brand of filament too. Some brands are a lot more susceptible to doing that than others.
yeah, these are the inland brands, probably the cheapest filament you can buy, I guess.
Yep.
Well, maybe not. I guess if you got it through AliExpress, that would be cheaper, but
Well, because it breaks occasionally, and it never breaks when I'm using it. It breaks when it's sitting idle here for a month or two. Then I go back to using it and I'll find it's broken. But I took the time one afternoon to get really, really good at rethreading it, and it's easy.
yeah, I have an old Melon, I think Melyan 150. And it is not easy to get the filament, and it's like, you poke it in, you keep feeding in it, and then all of a sudden you notice it's coming out the bottom of the housing, not out of the extruder. It's going to like, okay, man, pull it back out,
Yeah. Well, I just decided I had to get really good at it, and once I figured out the tricks, it's easy.
Yeah.
So I have a good story about filament breaking. I had the end of a roll. It was a few meters, I'd say. And I took it off the roll and put it in a Ziploc bag with a bunch of desiccant. I came back like 6 months later to use it, and it was all broken into like 2 or 3 inch chunks.
I had that experience too.
Yeah, you know what? I figured out what happened is because it wasn't in the roll, it had expanded, and that caused stress because it wasn't where it was originally wound.
Okay.
And so that's why the whole thing broke.
Hmm.
And again, that was really cheap filament, PLA.
Yes. Yeah.
So you don't think it was some chemical reaction between the desiccant and the filament, or?
No, I'm sure it was just stress.
Huh.
Yeah.
Because I've used desiccant in a bag before and it hasn't been an issue.
Mm. Yeah, I've got a
Does
bunch of
desiccant
samples
in a bag keep it dry enough?
What's that?
Does desiccant in a bag keep it dry enough?
In Colorado, it does. Yeah, for sure.
Depends how old your desiccant is, how much liquid it's already absorbed.
Yeah, you want to put fresh stuff in.
Yeah. Or heat up your desiccant to drive the fluid out of it.
Yeah, it just dry it out and
And you can use it again.
Yep.
I bought a bunch of reusable desiccant so I could do that. It's in nice little packages that have little tiny holes in them.
Mm-hmm.
yeah, that's a lot of the desiccant you buy in the little paper or cloth packs. You can dry them. Supposedly it's food safe, typically the gel, and you can dry it in an oven at a couple 100 degrees for 20 minutes, an hour. I forget what it is.
So I guess we all need humidors for our reels of printing material.
Apparently, a food dehydrator works very well to dry.
I've heard that too.
Yeah.
Yeah,
Yeah.
that's what we use.
I
But
use
we have-
airtight cereal box with desiccant beads. It works. I can get down to like 20% humidity in there.
Without drying it, just by putting desiccant.
Yep.
And I'm guessing you guys are much more humid than we are up here.
Oh yeah.
Mm.
Yeah, my house is running about 35 or 40% normally right now, this time of year.
Yeah, this time of year, that's where I'm at.
Yeah, I actually have a humidifier in my house to keep it above 15%.
Oh, wow.
Colorado's really
Colorado,
dry.
yeah. Yeah. Wow.
Yeah, we stayed at a friend's cabin in La Plata Canyon in Colorado.
Mm-hmm.
And at least I think it's in Colorado. I think it's the southwestern corner.
Yep.
And woke up and it's like all of our noses were so dry. It's like we didn't want to touch them. You know, they feel like they might crack and fall off. You know, it's like, oh God. You know. So extremely dry.
Oh well, that was Tom was the last on our list for presenters. Is there anyone else that has something or?
I could show my thing. It's not super impressive. I mean, it goes in a rectangle and.
If it goes, that's progress.
Oh yeah, I guess. All right, I gotta switch to phone mode. DPRG website. DPRG website. Hello.
Computer. Hello, computer.
Yeah. It's not cooperating.
Anybody gets that reference?
Oh yeah, that was on TV not that long ago. How quaint.
God, this is slow. Okay.
Yeah, I'm still waiting for that transparent aluminum.
Yeah, there you go. Yeah, the little phone's giving it all she's got. Okay, I am going to mute this.
You are muted, Ray.
Can you hear me now?
Yes.
Okay. Mute. Forgotten how to switch cameras on the phone. Oh. That was pretty simple to do. Well, now we can't figure out how to switch cameras. That's. Setting. Let's try settings.
Getting a little bit of an echo from you as well, Ray.
Yep. Okay, now it's disappeared.
Looks like your camera connection froze.
Okay. Well, I've done it before. Now I can't figure out what to do it again. Well, why don't we go on and I'll see if I can figure it out. Can you guys hear me?
Yes.
Yeah.
With severe echo? Okay. Well, why don't we just move on to somebody else? I got to figure out how to set this up. Not intuitively obvious.
You have 2 feeds with audio going right now.
Okay. That better? Sounds like it's an echo. Well, why don't we just move on to somebody else? I can't figure out how to change.
Ow, stop.
Okay, well, while he's working on that, is there anyone else that has something they would like to present or a question for the group?
I guess I can show what I showed at the meeting on Saturday that some of you guys missed. And that's the, I'm working on a time of flight sensor for my robot. It's basically a dual time of flight sensor. So I actually wired up the first sensor today and was playing around with it. So for the people who missed it at that meeting, it's basically got 2 of the DXL C30 somethings time of flight sensors. Each on basically each one can pivot. So it's basically servo controlled, and the idea is to try and do a kind of a low cost semi LIDAR with it. So I still haven't wired up the servos yet, but I got one of the sensors working today.
Mark, are those single laser sensors or are they 8x8 arrays?
Single.
Okay.
They're the ultra cheap ones. They're the Sony sensors. The I forget what it's the VLS 3L LOX sensors.
What's their sensing range?
About 3 meters.
Okay. And with the 2 articulating servos, are you planning on using them like lizard eyes?
The idea is to kind of use them like a scanning LIDAR. So basically, to be able to scan across to see what's in front, and also to be able to change the elevation slightly so that I can look at different heights.
So they're both sensors are going to be front facing.
Yeah.
Front facing, and then being able to sweep left and right.
Yep.
Okay. And what are you using to communicate with them? Is it like a Raspberry Pi over I2C, or?
It's a Raspberry Pi Pico over I2C.
Okay.
Mark, why two? Why not just one? Visual effect?
Visual effect. And the idea is similar to what Ray was doing with being able to essentially watch the wall with one and scan forward for the cans for the other.
Okay.
Because it can actually go out at, I'll actually be able to pivot them out to 90 degrees.
That's cool.
There's-
I hope that works out.
Just a fun challenge. I figured I'd see if I could get it to work.
Yes, I see this as a part of your practice of developing a number of modules that you can
Yep.
place on your bus. I like that.
That's the idea.
Yeah, I'd be very interested to learn more as that develops.
Yeah, I've got I have the second generation of the boards are on the way from China right now. So hopefully I'll have some more to demo on that in the next week or two. I guess this was the other thing that I was playing around with today, kind of inspired by Robby. It's basically basically a threaded cam system for basically moving a joint. So if I untape it here and try not to unravel everything. So basically with a really light pull, you can move and get quite a bit of force, although I just untangled it. I just basically got it's a whole bunch of, can't really see it, but basically a whole bunch of pulleys, basically to do a reduction on the joint. So it's just something I decided to kind of play around with. So this was just a quick 3D print today. Quick design and 3D print.
Like a little block and tackle.
Yep. But it actually works really well.
Yeah, bring that tomorrow. I'll check it out.
Can you guys see my image?
Yep.
Oh, okay.
Yeah.
Anyway, so I've set this on basically the robot course, or parts of it. I don't have the edges up or the goalposts up yet, but it doesn't matter. I'm not going through the goal right now. But anyway, what this should do is move forward until it reaches 30 centimeters from the front wall, and it should track parallel to the side wall. Then it should move left across the goal and then back until it's a meter from the front board, and then back to the right and just keep looping around. And it's, I know speed is everything for that contest, but right now I'm going a little bit slower, but I'm probably could go at least twice as fast. Yep. Oh, there we go. Didn't do what I thought it was going to do. So now it should go forward.
It's because you're in demo mode.
Yeah. Off to the left. Not tracking very well. Okay, back. Ooh, this is getting creative.
So it didn't do what you want to do. You didn't do what it thought it was going to do. We just need to have that on a button that just like the easy button, you know?
Yeah, it's a little shifted.
I'm sure we all say that so much. It just should be just a clicky sound effect at this point.
Yeah. That's cool. I do love Mecanum wheels. They're so cool.
Anyway, so that's all it does
Nice.
for now.
Are you doing conditioning and sort of odometry?
Say that again.
Are you doing any odometry?
Nope. I'm just looking at the 2 distance sensors and trying to figure out, where I'm at on the course based on those. So, according to the guys that used Mecanum wheels before, I guess you get quite a bit of slip with the wheels, and odometry might not be that accurate. So
Yeah, well, visual odometry, like something with the, these optical things, right?
oh, say that again.
Yeah, well, yeah, I know with the wheels you probably can't do it, but on these optical sensors you could have pointed at the floor.
Oh, you mean at the goal in front of it and beside it, or is it? Oh, that's where
Oh, at the floor, get more position, get some sort of.
Yeah,
like the optical flow, like
yeah,
Like a mouse.
okay.
How most of the first robotics type people do it that I see it, they've got a basically an X and a Y follower wheel, and that has encoders on it and all that kind of stuff, and they let that track the odometer.
Okay.
What they are.
Let's go downstairs. Come on.
They
Yes,
don't
sir.
depend on, because they know they're going to get clipped all over the place, so they don't depend on that at all.
Ray, do you have suspension on that at all?
No. Yeah, I think this is very close to the platform that you have, Carl.
Uh-huh.
Yeah. So
There
yeah,
seem to be a lot of
curious,
knockoffs on it.
say that again?
There seem to be a lot of knockoffs on that platform.
Oh, yeah. Okay, I'm gonna get out of this one.
You are muted on your other one, Ray.
Anyway, that's kind of a start. I just wanted to see if how well it tracked. It does have, it is running a PID loop for each wheel, but the flooring is not perfectly flat. It's it's textured and it's got ridges along where the boards meet, and so I don't know if that's what's making it be a little flaky. It's kind of weird. Like, to follow the wall, you have a PID loop for each motor that tries to get each motor to spin at a certain RPM. And then you can use the distance readings, if it gets too far away or too close, to try to steer it. And that's a second PID loop that runs. So it's an awful lot just to get these motors to spin. It's like,
Do you use a gyro or anything to keep pointing in the same direction, or do you just hope that the wheels are all spinning at the right revolutions?
Nope, no gyro so far. Just, the 2 distance sensors. And I'm going to try to maintain, the robot frame parallel to the long wall.
How are you going to maintain it parallel, though?
With distance sensor readings and, changing the drive on all 4 wheels to, like, it gets right now I've set it for 30 centimeters away. It's about a foot. Each of those boards is about 2 feet. And the front part of the goal with a like pretty close to a 3-foot opening for the goal. So 1 foot in or 30 centimeters from each side, I can always see the board in front of it with the front facing distance sensor. So
You have just one sensor to the forward and one to the side.
yeah, one to the right, one facing forward.
So if the thing starts to rotate somehow around the z-axis, you have no way to measure that.
No. So it's whenever it moves forward, and I tried moving back, but I think I need to have a distance sensor that's on the back of the robot, because it doesn't work nearly as well following the wall in reverse as it does going forward. Forward, it's pretty good. It corrects fast enough and stays the right distance away. It doesn't do crazy slow loops or anything like that, or oscillations back and forth. So it's the KISS robot. It's the keep it as simple as possible. So that's what I thought. If I only move to the right or to the left or forward or back, and I can sense the long walls all the time, I should be able to move pretty much anywhere in the course and know where I'm at. And my theta would always be, I guess, 90 degrees, always pointing forward. So theoretically, anyway, who knows what's going to happen on contest day? Yeah. So, but yeah, probably an IMU would work better. Is that what you did with yours, Carl? I know you did. Didn't you do like the four square?
I didn't use distance sensors, but in my experience, the gyro or IMU is critical, because what'll happen is that, at least as I've seen, it starts to build up a rotational error around the z-axis, right? So it slowly starts to, whatever causes it, it just starts to rotate one way or the other.
Yeah.
And sure, your sidewall pid loops will tend to move it closer or further from the sidewall, but at some point it's going to be rotated so far that the angle you're not going to measure normal to the sidewall, right?
Yeah.
So it's going to get all out of whack. And that's what I found, was that the putting a gyro in there to always keep it pointing it north. Or I used a compass, which wasn't the best of ideas, but it worked remarkably well. It made a huge difference in how accurately and how repetitive it could follow just a simple time and velocity kind of profile.
Okay.
Oh, the IMU, just give it a heading pid loop so it always aims in the same direction. With that and your sidewall sensors, and it'll be, I think, really good.
Hope so.
Oh.
So it can move pretty fast, and even though I'm only moving, well, I could do diagonal movements too. That's not that difficult, but that was kind of the goal, is to always keep either parallel or perpendicular to the boards that make up the course. So could be another one of those harebrained ideas, but
Nah, you just need a loop.
You
just need a heading loop, and you're there.
Yep. Yeah. I don't know. The distance sensors work pretty good. It seems like pretty much all the way in the back, which is the sensor's probably a foot ahead of the back wall. So, but at close to 9 feet, it can still measure the front board. And, so it's not like you need, a sensor, or it's not like you have a sensor that only goes like 5 feet, and then you need another sensor to go the other 5 feet, one facing backwards, one facing forward or something. But so they're But that's probably about the limit of those. I don't know that they'd go much further. So,
Ray, I can appreciate your need to go simple. I worked with this Tribot Mecanum drive and tried to make it universally applicable to convert XY coordinates into what I needed to drive it wherever I wanted it to go. The math is just a mess.
oh yeah. I imagine with 3 wheels like that, it's really
actually,
complex.
this thing has tachometer feedback or pulse feedback on every drive. What I found was on smooth floors, of course, it skidded around a bit, but on the living room rug, it worked actually extremely well.
Huh. Maybe I need to bring in my own carpet and whip it out on the course. I don't know if that's going to be allowed. Don't tell Doug. Don't tell Doug.
I don't remember it saying you can't put carpet down on the course.
Yeah, as far as I know, there's no rule against that. So, I show
Just cover it in hairspray.
Oh, there you go. Little stickiness. So, but
Well,
yeah,
Ray, we gave you a gold star for the autonomous running. That's excellent.
Good. Gold. It's a gold Special Olympic star. I guess in my case, it's not that impressive.
We'll take it for what it is.
There you go.
Thing.
I should have got Paul's little wand before he left, so I could wave it anyway.
Well, thanks, Ray. Does anyone else have anything they'd like to present tonight? Well, it's a quiet night. I guess we call it.
I guess so.
Yeah.
Later, Gators.
More time to work on robots.
Yeah. Cool.
Take care. Good night.
All right. Good night, everyone.
Good night.